notes, and you're actually listening to what I'm saying as you take the notes. Okay? So stay quiet, pay attention, take the notes. So today we're going to go over arc measure within a circle. Okay, so the first thing I have here is a central angle. That is an angle whose vertex is at the center of a circle. Okay, so the vertex is at the center of a circle. So from point B, that's your center. If you have two radii from that center hitting the edges of your circle, this angle right here is called a central angle. Okay? Because it has the center of the circle made up as its angle. Okay, it's a central angle. How many degrees are in a circle?
360.
I only know that because I do 360s on my jet ski.
Okay, there are 360 degrees within a circle. So the sum of all of your central angles within a circle has to be 360 degrees. Okay, so if you were to add up these angles here, you should get 360. So in number 4, I want to solve for x in each of these circles. Okay, so in letter A, my x value is right here. I know it's kind of hard to see. I have one central angle of 130 and another that's 90. Well, I know all of the central angles within my circle have to add to 360, so I can just take 360 and subtract the angles that I know. Okay, so I'm going to subtract that 130 and subtract that 90 degrees. And x will be 140 degrees. Okay?
Is that how we're doing?
Not quite.
Huh.
Okay, letter B. Okay, we're going to do the same thing. This time we have an angle that's 40, one that's 85, one that's 90, since that's what that box means. Okay, it is 90. And then we're looking for x. So again, all of those angles have to be 360, so I'm going to take 360 and subtract each of those. And I got x to be 145 degrees.
Holy smokes.
Okay, so you can find that missing central angle if you're given the others. Are we good? Any questions on that part? This part isn't that bad. So next I want to talk about the arcs of your circle. So an arc is a portion of a circle defined by two endpoints. A central angle separates the circle into two arcs. Okay, so here I have Q, that's the center. It hits points P and R, right? So that central angle splits it into this first arc here. That would be around this outside part. And this second arc on the other side here. Okay, so your arcs are just those outer parts of your circle. Not the whole thing all the way around. Okay, just from one endpoint to another endpoint. That's called an arc. So the measure of each arc is equal to the measure of its central angle. Okay, this is an important piece, and we're talking about the measure. Okay, so the measure of the arc. Tomorrow we're going to go over arc length, which is different. Okay, this is measure. Arc measure has to do with your central angle. So say this central angle was 130. Okay, the arc across from that, okay, after it hits the endpoints, would also be 130. Okay, so the arc measure is the same as the central angle. Okay? This is only true if it comes from the center. Okay? Central angle, it's the same. Now we do have different types of arcs depending upon their measure. So we have a minor arc. Okay? That is the shortest arc connecting two endpoints on a circle. So at the right there, I have a central angle of x degrees. It hits points A and B, and it makes up this arc here. Okay, so that arc has to be less than 180 degrees. Okay, so a minor arc is less than 180 degrees. Okay, and minor arcs are named with two letters. Okay, so you know how you name a segment with two letters, right? You name an arc with two letters as well, and those two letters would have to be its endpoints. So in the arc over here, our endpoints are A and B. Since it is a minor arc, I would say this is arc AB, and you just put a little arc over the top of them.
All good.
Okay? So like when we were labeling segments, you'd put a segment above them. Now you just put an arc above it to label the arc. Yes?
How do you know if it's minor or not?
So if it's minor, it's less than 180 degrees.
Yeah, but like
In the picture,
no,
what do you mean?
in the letters. Like when
We'll probably have to figure out.
So the only arc that's labeled with two letters is a minor arc.
oh.
So if it's labeled with two letters, you'll know it's a minor arc right away. Okay?
Yep.
The next type of arc is a major arc. Okay? Your major arc is an arc that is greater than 180 degrees. Okay? So your major arc has to be the greater one. So that would be, if I have endpoints A and B here again, that would be the one around the other side. Okay, so that would be your major arc. Now, major arcs are named with three letters. Okay, so you're going to take three letters to name this major arc, and they have to go in order of the arc. So to the right there, I could say that this is arc from A. I would have to go to D, then to B to end. Yes. So I'd have arc A, D, B. Now that that point D has to be in the middle, okay? It can't be one of your starting points. Now you could also label this arc B, D, A. So you have to start with the end point and you have to end with the end point. Okay, that other point in the middle is just in the middle of that arc. Okay, so it has to flow in order. The last type that we have is a semicircle. Okay, that one is 180 degrees. So for it to be a semicircle, it has to be 180 degrees. So it is made up of a diameter of your circle. So the end points are also the end points of the diameter going through the center. Now this arc is also named with three letters. Okay, so you'd have to make sure when you're given an arc with three letters, if it's made up of the diameter, so if it has a diameter, then it's a semicircle. If it's not a diameter, then it has to be a major arc. Okay, so by looking at your picture. So in this case, starting with one of my endpoints, going around, okay, this would be arc A, D, B, or B, D, A. So again, start with the endpoint, flow in order. Questions on your arcs so far? Minor, major, semicircle. All right, then at the bottom, number 7, I do have an example here. So PM, okay, segment PM is the diameter. Okay, so from P to M that goes to the center is the diameter of that circle. We want to identify each of these as a major arc, a minor arc, or a semicircle, and then find its measure. So 2A, we're given arc MQ. Without even looking at the picture, what does that arc have to be?
Minor.
It has to be minor. Okay, so next I'm going to look at my picture because I do want to find each of the arc measures as well. Okay, so MQ is this one right here, right? It is 65. So to get that, I know from M to P has to be 180 degrees since it's a straight line. And I'm given that this angle is 115. So I just subtract 115 from 180 to get that missing angle there, and it is 65. Now, since that's a central angle, and you're looking for the arc measure is the same as the central angle, so the measure of that arc would be 65. Okay, next we want to look at 2B here. That arc is MNP. Again, it goes in order. So I'm going to start at M, go to N, and then to P. Well, that arc is made up of that diameter, so what does that have to be? It is a semicircle. Okay, what does the semicircle have to equal? 180. Okay, the last one, we have arc M to N all the way to Q. Okay, so this entire arc around the outside here. Okay, that is a major arc, good. It is bigger than 180. So how can I find the measure of that arc? There's two different ways. Subtract. Yes, so you can take 360, which is the total circle, and subtract the one arc that's not part of that one. Okay, so 360 minus 65 would give you this arc of 295. Or, since you know this angle right here is 90, this one also has to be 90. Okay, they create 180. You could just add all three of those together to get that entire arc there. Okay? Questions on the front so far?
Congruent arcs, oh my gosh.
All right.
With the arcs in the circle. Or
Just quickly.
If you go to the next page then, so on the back, we are going to talk about congruent arcs. Okay, so congruent arcs are arcs in the same or congruent circles that have the same measure. Okay, so congruent arcs could be in two separate circles, or they could be in one circle just having that same measure. Okay, so arcs that are the same. So number 9, in the same circle or congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So if I have angle 1 congruent to angle 2, okay, if I know those two angles are congruent, I know their arcs have to be congruent. So then I can say arc FG is congruent to arc JH. Okay, so since those central angles are congruent, those arcs are congruent. And I underlined that if and only if statement because you can read this backwards as well. So if I know that those arcs are congruent. So what it says here, so FG is congruent to JH, then I can say angles 1 and 2 are congruent. Okay, so if you knew those arcs were congruent, then those angles must be congruent. Okay, then we have adjacent arcs. Adjacent arcs are next to each other. Adjacent always means next to. Okay, so it has to be next to it. They have exactly 1 point in common. Okay, so they share a piece of one of those radii in your circle. So we can use that for the arc addition postulate. That's the measure of an arc formed by 2 adjacent arcs. I think I spelled that right, yeah. 2 adjacent arcs is the sum of the measures of the 2 arcs. Okay, so you just add your 2 arcs that are next to each other together to get the larger arc. Okay, so it's like your segment addition postulate. If you know this piece is 4 and this piece is 5, you can add the 2 that are next to each other together to get the total of 9. Okay, so same thing with your arcs. Add the 2 pieces together, you can get the total arc. So we are going to find the measure of each in number 12. Okay, so number 12, we want to find the measure of arc CE. Okay, so C to E is here. It is a minor arc, so I just need this little one here. If I said C to B to E, that would be this one all the way around the back. But since it's just those 2 letters, you do the minor arc here. So what I want to do is find each of these missing angles now. Okay, before I even try and find CE, I'm going to find each of these missing angles. So I know this angle is 90, right? CA is the diameter. So how can I find this little missing angle here?
180 minus 90 minus 63.
Good. So I can take 180 minus 90 minus 63 to get that missing angle.
Oh, I knew that. I did the opposite. I added 63 plus 20.
Okay, so that angle is 27. BE is a diameter. AC is a diameter. Those are 2 intersecting lines. What do I know about these 2 angles? They are the same. Why? What type of angles are those? They're vertical angles. Okay, so those are vertical angles, so they are congruent to each other. Okay, then the last angle I was missing was this angle right here, this larger one. Well, again, AC is a diameter, and I know that piece is 63, so I can just subtract 63 from 180 to get that missing last angle there, which is 117. Okay, now that I found all of my missing angles, I'm going to now find all of my arc measures that it wants me to find to the left. So again, going back to letter A, finding the measure of arc CE. So from C to E, well, to get that arc, I just have to add the 2 angles that it's comprised of. Okay, so I have 90 plus 27. $117. Okay, letter B then. We're finding the measure of arc ABD. So go from A to B to D. So we're going around this way. So I need all 3 of these arcs. Okay, so since all 3 of those arcs are connected, I just have to add all of their measures. So 117 plus 63 plus 27. Okay, and then letter C. This is a minor arc, AD. So from point A here to point D, I need this angle of 63 and this angle of 90 to get that entire arc. It's 153. The last one, letter D, we're finding this arc A to D to B. Okay, so all the way around. So we can either add up all four, or we can take 360 minus that missing arc. You do get 243. Okay, any questions on finding your arc measure?